dt. I'd like for you to put a star next to this problem, just to remember that today, September 19, 2022, was the day you did this problem. And you'll remember this problem because it's a pain in the ass, all right? It's not terrible, but it's just like, oh, man, really? Okay, so here's the deal. If you look through our steps, all right, do you remember the first step said if cosine is odd, right, we'll peel off a cosine? Well, cosine's not odd, right? The second step said if sine is odd, we'll peel off a sine, right? There's no sines. So that means there's only one more thing, the third thing on the steps. The third thing on the step says, if the powers of both sine and cosine are even, you will have to use the half-angle identities. These are the identities I just showed you, right? All right, so they are even, so we are going to use the half-angle. So here I go. I'm going to rewrite this as cosine squared of beta t, that squared, right? That's what that is? Right, I cannot, the half-angle identity that I'm going to use, I'm going to put it back up here. The half-angle identity I'm going to use is this one right here for cosine squared. Okay, that's one I'm going to use. But the half-angle identity has to have squared. It can't be fourth, okay? You can't change that. Some students think, oh, I can change this formula and make that a 4 and make that a 4. No. It has to be squared, and then you can double the angle. That's it. So I have to rewrite this fourth power as a squared power squared. All right, here we go.
Okay, so
yes?
where does the 1/2 go on this?
Yeah, where's it go? Well, we're going to replace this right here. That right there alone is getting plugged into that formula right there, okay? So in parentheses, right, because all of this is being squared, in parentheses, I will have 1/2 parenthesis, right? 1 plus cosine of, and what goes in there? 2 beta t. 2 beta t. You're doubling the angle, right? You're doubling, whatever the angle is, you're going to double it. So I'm going to put 2 beta t here. Does that answer your question? Is everyone clear on that?
And you cannot pull out the constant.
You can't pull the constant out because it's in the parentheses, right? Yet. I'm about to, though. All right? We're good here, though? Come back over here. Now, I'm going to rewrite this as, okay, this is multiplication, right?
Yeah.
This is multiplication. So just remember that if you have two things being multiplied and being, let's say, squared, you can do the squared on each one, right? That's a property of, well, algebra, right? So I'm going to take this 1/2 and square it. That's 1/4. I'm going to pull that out of the integral. And then I'm going to have whatever's in parentheses here, right? I'm missing a parenthesis, aren't I? Yes, I am. Right there, I'm missing a parenthesis. Because this parenthesis is the thing being squared, and then this parenthesis has the 1 plus cosine 2 beta t, and that parenthesis has the 2 beta t. I was missing one, sorry. So that's me squaring this, right? And now I have to square the 1 plus cosine 2 beta t. So I'm going to write that down. I need to square it, right? 1 plus cosine of 2 beta t squared dt. Who has questions? Anybody? Sure? Now, unfortunately, we cannot just square each one of these, right? Because there's addition. What we can do is FOIL it out, though, right? And we're not making any substitutions, right? This step doesn't say anything about substitutions. It just says use that half-angle identity. So over here on the side, let me do that. Let me do the scratch work. I want us to do 1 plus cosine of, what was it, 2 beta t times itself. 1 plus cosine of 2 beta t, right? I'm going to multiply it times itself. and then expand, right? So 1 times 1, 1. 1 times that gives me cosine 2 beta t, right? Then the middle one, I get plus another cosine of 2 beta t, and then I do this times this, and now those are the exact same thing, right? So that's going to be plus cosine squared 2 beta t. These two terms are the same, and I'm adding them, so I have 2 of them. All right, that is just the squared part right here, right? And I have a 1/4 in front of everything. So I'm going to rewrite this whole integral, right? I'm going to rewrite this whole thing, 1/4 integral, and then everything I have over there is going to be inside the new integral. 1/4 integral 1 plus 2 cosine of 2 beta t, right? Plus cosine squared of 2 beta t dt.
Could we pull that 2 out? Or?
We could pull the 2 out if there was a 2 in all of these, or because there's pluses and minus, well, there's just pluses between these, can't we split this into 3 separate problems? If you did that, then you could put, like 1/4 integral of this, and then you could put the 1/4 here and bring the 2 out with the 1/4. I'm just going to leave it for now, though. Is that all right? Any other questions? So this is where we are, right? What's the antiderivative of this? T, right? T. Do you know the antiderivative of cosine of 2 beta t? Well, 2 cosine beta t. Can we do that? Yeah, this is just a cosine, isn't it? But I'll have to scale because I've got this in front. We've talked about this. This is linear. We should, okay, so yes, yes, happy faces. Yes, yes.
You're going to have to do it again.
Yeah, this is a cosine squared. I can't do it. But I can use that formula again, right? I can use the power reducing half angle formula to rewrite this, all right? So we're going to have to do that now. So I'm going to continue over here. Let me do it this way. I think I'm going to really kind of take my time with this one. I'm going to rewrite this as 3 integrals. 1/4 integral 1 dt. Okay, plus 1/4 integral 2 cosine of 2 beta t dt. And then plus 1/4 integral cosine squared 2 beta t dt. I'm splitting it into 3 separate integrals. That way I can keep track of everything. This first integral, the antiderivative 1 was t. So I have 1/4 in front of t. Now I'm going to have a plus c, right? But I'm just going to throw a plus c at the end of everything. All right? I'm not going to do plus c for each one of these. All right, this one, plus 1/4. Okay, let's see if we can recall how to, oh wait, there's a 2 there, right? I'll clean up all the constants in a minute. 1/4, 2. Antiderivative of this is sine, but we also need to take care of, there's a 2 beta t in there. 1/2 beta. Then sine of 2 beta t. That's the antiderivative of cosine of, the antiderivative cosine of 2 beta t is 1/2 beta sine of 2 beta t. We talked about that, what, 2 classes ago, I think? So that's all good, right? We've got all that. But then we have plus 1/4, and then here's where we have the problem, right? So we go back to the steps. It's like, oh, if this is odd, peel off a cosine. It's not odd, right? If it's sine to an odd, we peel off a sine. It's not sine to an odd, but it's cosine even, right? So I'm going to use that formula again for this. So that becomes 1/2. Careful. Hold on, let's ask. Marianella? Did I say that right? Hey, how's it going? How do you feel about using that formula on this? Feel okay about it? Okay, so it's 1/2, and then what would go in here? 1 plus cosine, drum roll. So what is the formula telling you to do? Whatever was in the cosine, right? Whatever was in there, call that x, right? In the new thing, it's going to be doubled. So what would happen if you double that? 4 beta t. 4 beta t. Everyone got that? dt. Marinella, you got that? You understand? Yes? Question?
No.
Are you sure?
Yes.
Yes?
Since it's not squared this time, we can pull that 1/2 out, right?
That's right. See, this is not squared. So what I'm going to do now is I'm going to break this into 2 separate integrals again. Or I can just, I mean, it depends on how much you can do. Like, you know, this is all comfort level stuff for you. You know, like, do you want to break this into 2 separate integrals now? Do you want to do it all together as one? It's kind of your call. Let me come back over here and see where we are here. Oh man, I wish I could leave this all up. All right, so we are at, I'm going to clean it all up, 1/4 t. And then the next part, isn't it 1/4 beta? 1/4 beta, right? Because I can just like, there's a couple of ways you can do this. I'm going to cancel those 2's and I get 1/4 times 1 beta. So I get 1/4 beta sine of 2 beta t. Okay, and then I have plus, I'm going to write 1/8, pulling out the 1/2. And then in here, I'm going to have 1 plus cosine of 4 beta t. 4 beta t dt. So just pulling that 1/2 out right here. And then these I can just do individually, right? Just remember there's a 1/8 in front. So let's see who's up here. Okay. Victoria? No? Yes. Uh-huh. Yes. Can't be 2. Uh-huh. Yes, I'm taking that and multiplying by 2. So when I multiply that times 2, I just get 4 beta t. Michaela? Where's Michaela? Okay. What I'm doing here, I'm just like putting a dot on the roster and I'm looking over to see who it is. So that's, Michaela, you're up. Any questions up to this point? Okay, can you give me the antiderivative of both of these? Feel okay with that? So what's the antiderivative of this? T, okay. And then this one? 1/4 beta. Good. Sine 4 beta t. Very good. That's just the antiderivative of those, right, everyone? Yeah. And so we do have a 1/8 in front of all this, don't we? And then plus c. And then everything else comes down, right? So this, and then this. Okay, we're almost there. Got a little bit more to do here. Any questions on that? So here's where I am. I have 1/4 t plus 1/4 beta sine 2 beta t. Distribute the 1/8 through here, plus 1/8 t plus 1/32 beta sine of 4 beta t plus c. There you go. Still not done because these two are like terms, so you could add those together, right? 1/4 and 1/8 together is 3/8. So your last line could be 3/8 t plus 1 over 4 beta sine 2 beta t plus 1 over 32 beta sine 4 beta t plus c. There it is. What do y'all think?
Sucks.
Yeah, kind of sucks. No, you know what really sucks? Cosine to the 6th power, which is in your homework. Yeah, that sucks because here we had to use that half angle twice, right? For cosine of 6, you have to use it 3 times. And keeping track of everything is a real pain in the butt. So, you know how I said put a star on this one? 2 stars on that one for your homework because you'll remember that one. You'll probably have to write sideways when you do it on your paper. Yes?
What did you do the last step?
What I do, which step?
From that to the answer.
Added these two together?
Oh, that's it?
That's it.
All right.
Yep. I think I didn't miss anything, did I?
That's right.
Yeah, that's right. Okay, y'all doing all right? What's up?
What would that be used for, like, I guess, in real life? What would that be?
You're asking the real life question.
Yeah.
Like, where is this? Well, look, please remember that everything we're doing here is just the tools, right? We are going to start, after this, after we're done with all this torture, right? We're going to start applying this, right? So, yeah, we have to tie this to something. Like, what is the antiderivative useful for? We haven't done that yet. But I promise you we will. I mean, we haven't done that here yet, right?
I mean, we kind of did, like, with physics. And,
Yeah. So, I mean, if you're asking where do we ever need to do antiderivatives, well, all over the place.
not that. Just like this formula, like, what would be the applied use of? It'd be, like, area?
Well, this would be the area underneath cosine to the 4th beta, what was it, beta t? Yeah, right? You need to give me like an interval, but yeah. And that could represent a lot of different things. Total work force, total work done. There's a lot of things it could be. So there's something to remember about this that I think you're bringing up a good question because a lot of times when you're sitting here, you're like, but we can just go to, Wolfram Alpha. We can just get these answers, right? I mean, like, so why are we actually putting ourselves through this? To me, the answer to that is pretty simple, is that not everybody can do this. Not everyone can manage all this stuff and process this information this way. Not everyone can. The type of people who can are the type of people that you want building bridges, that you want building airplanes. People who can't process information like this, this is training your brain to think a certain way, right? Problem solving, critical thinking, right? That sort of thing. It's different than like reading a book and analyzing like how it makes you feel, You know what I'm saying? It's just a different part of your brain. So here we're just training our brains to think a certain way. And then that will translate very well into the real world when you're computer programming, engineering, whatever it is, right? That's the way I look at it.
Saying they remember all this? Saying that they remember all of this?
Well, I wouldn't expect that the student coming out of Cal 2 later on is going to know how to do all this at all. But I can tell you that when they're faced with a problem, they don't give up. That I can tell you that. You know what I mean? Like that degree, that engineering degree means that you are like hardened, right? Like you know how to overcome a lot in terms of things that are tied to STEM. That's the way I look at it. I mean, I could be wrong, but I'm going to have a former student of mine come in here. I need to schedule the appointment, but he had me for Cal 2. He started out in 0320 here. I'll let him tell the story, but he started out 0320 here, and he just started his PhD in engineering. I'm not sure which engineering, but he just started his PhD program. So I'm gonna have him come in here and talk to y'all just to kind of give you like his perspective, because hearing from me is one thing. Hearing it from someone else, you can ask him, when do I need to know this? And then and he'll have an answer for you. He's getting paid to do his PhD, so he's working for a company in California, And so his research is actually what they want him to do in California, so he's getting paid to do his PhD. Pretty cool. All right, let's do another problem. Another part of that story that I like is the fact that, yes, you can go from here and go compete in a university. You know, I mean, because when you get out of here, you have to go compete with other people as well, right? I mean, you're competing with each other, right? But you also have to compete with other people from around the state and around the world that have come and want to also be engineers, right? So you can go from here to that and get through that successfully, but he'll tell you what you need to do. I can tell you all day, but that's like telling my daughter to clean her room. Okay, what happens if we've got tangents and secants, right? Well, there's a whole set of steps, right? There's a whole set of steps again, right? If we had tangents and secants. So I'm not going to read the steps. I'm going to go to a couple of examples, all right? I shouldn't say that. That's kind of rude. I'm not saying that when I tell y'all things that y'all are like my daughter doesn't listen. I mean it more like, I think it means more when it comes from a student who's like just gone through that, you know?
And not someone that's spent the last 30 years in the future.
30? Easy. Easy.
Oh, sorry, 28.
Easy now. Easy. I did start young, but I wasn't that young. 30 years? 27. No, I'm kidding. I taught my first class in 2000. All right. So what do we do here? Well, let's look at the steps. All right, if you have tangent to the mth power, you see the m up there? And secant to the n power with n being even. Do we have that? Yes, okay, so we're going to follow this first step. What does it say to do? Factor out a secant squared x. See, it's saying, look, if you've got tangents and secants together, and your secant has an even power, then you should be able to pull a secant squared out, right? Okay, so do that. That's what it says. So I'm going to pull out the secant squared x times secant squared x. Just rewriting that, right? Now what? That leaves us with an even power of secant, right? So that leaves us right here with an even power of secant. Now, when we've peeled this secant squared off, secant squared x dx, secant squared x is the derivative of what? Tangent, right? So that secant squared x dx is the derivative of tangent. So that means I want to try and rewrite the whole integral in terms of tangent, which I already have tangents out here, don't I? But this is not a tangent. So I can use the Pythagorean identity to rewrite this in terms of tangent. That's what I'm going to do. So I'm going to rewrite this as integral tangent to the fourth x, and then in parentheses something, and then secant squared x, dx, secant squared x dx. I don't know what, this is just random. Lauren? Hi, Lauren. Lauren, how can I rewrite this in terms of tangent? Secant squared x. Lauren? Yeah. Oh. Is it? Look over here. Can you see the bottom line of that or no? 1 plus tangent squared x. Okay? Now everything's in terms of tangent except that secant squared x dx, which we know is the derivative of tangent. So we're going to make our basic u sub now. And George? Where's George? George. All right, George. What's our sub? Okay, so use tangent here. What's the derivative of this, George? No? Yeah, that's right. That's exactly why we're doing this, right? Because there's its derivative. Okay, I'm going to stick with you, George. All right, so let's rewrite this. So this becomes u to the fourth power, okay, parenthesis. 1 plus u squared, good. And then finally, what's this? du. Okay, good. All right, good, good. Javon, you're up. How would, what's that? Distribute, yeah. Okay, so what are we going to have? U to the fourth. U to the sixth, yep. du. Antiderivative, Javon? Yep. And now just plug in u is tangent, and we're done. Yes? So 1/5 tangent to the fifth x, it was x, yes, plus 1/7 tangent to the seventh x plus c. There it is. If you've got tangents and secants mixed up, and your secant has an even power, you're going to peel off a secant squared, and then you're going to rewrite everything else in terms of tangent, and then you're going to make the substitution. Tangent is u, secant squared will be the derivative, rewrite everything, and you're there. Yes? All right, let's look at the next one. Tangent to the fifth x, secant cubed x. So the previous problem, we had secant to the fourth power, so we peeled off a secant squared, right? Secant squared is the derivative of tangent, which is like why we did it, right? Here, because we don't have an even power, right, of secant, it's an odd power, we can't peel off a secant squared. I mean, you could, right? But what would be the problem? I'm just going to show you why we can't do the same thing we just did. What would be the problem? If we did tangent to the fifth x, secant x, if we peeled off the secant squared x dx, right? If we did this, we know that that's the derivative of tangent, yes? But now you need to rewrite the whole integral in terms of tangent. You can't rewrite secant x in terms of tangent because you can't use a Pythagorean identity because this is not squared. Understand? So you can't use this method. So what we're going to do instead is we're going to reverse this. Instead of u being tangent, we're going to let u be secant. What's the derivative of secant? Secant x tangent x, which means I'm going to peel off a tangent and a secant from that expression. Right now it's in the steps. What I'm saying is in the steps, but here I'm going to peel off 1 power of tangent and 1 power of secant. That will leave me with a secant x here and a tangent x here, dx. You'll see how I peeled one of each?
Yep.
By doing that, by peeling one of each out, I hope you can see that this right here, right, that's my du. That's the derivative of secant. So I need everything else written in terms of secant, right? Not tangent, but secant. So the only thing I need to work with here is what? The tangent to the fourth. I need to somehow rewrite that as a something with secants. So I'm going to rewrite this as tangent squared squared. Leave this secant squared alone. Leave this secant x tangent x dx alone. Yeah, so now we have to use a Pythagorean for tangent squared, so use that same identity, solve it for tangent squared. What is it? Secant squared x minus 1. Then squared, then secant squared x, and then secant x, tangent x, dx. Any questions on where the secant squared x minus 1 came from? No? Gabriel? How's it going, Gabriel? What's my u sub? Secant x. Okay. So u is secant x. And the derivative of that, Gabriel? Secant x, tangent x, dx. Okay. You feel comfortable rewriting this or telling me in terms of u what this will be? Okay, go for it. Good. Du. That's it, right? Good. This is very similar to a problem we did earlier, isn't it? Where we had to expand this out. Except we have a minus in here, so it's going to be a little bit different, but it's the same principle, right? So I'm going to go quickly through this now. This is going to be integral. This will be u to the 6th minus 2u to the 4th plus u squared du. So I did the expansion mentally, and then I distributed u squared through that, and I get this. Now antiderivative, right? Okay. Dot, dot, dot. Let's move on. I think y'all have got it from there. The next three examples are B and C I've already done. Do you remember B, the integral of secant x, was the one where I told you someone had figured this out and like we would probably never think of doing this, right? Okay, and then the C we did with integration by parts. So I've done B and C. I haven't done A though, so let's do A. The antiderivative of tangent. Now we should know, everyone here should know that the antiderivative of tangent is on your formula sheets, right? Your formulas have this. Oops. Where is it?